皆さん、こんにちは。中大阪神戸総領事館広報担当領事のアリシ
Melissa Edwards, Public Affairs Officer at the U.S. Consulate General Osaka-Kobe. Thank you for participating in the online lecture on plastic waste issues and the importance of STEM education, hosted by the U.S. Embassy in Tokyo and the U.S. Consulate General Osaka-Kobe. As you know, 80 million tons of plastic waste is flowing into the ocean every year and has become a global issue. By 2050, it is said that the mass of plastic waste is going to exceed that of fish. Fragmented microplastic waste may impact human health through the food chain, which is a concern. As a measure to counter this issue, stores started to charge on plastic shopping bags starting this July, and I'm sure many of you have been paying attention to this issue. STEM education stands for science, technology, engineering, and math. The aim is to develop talent who can adapt to changes in our society and to find creative and original solutions and to create new values. Today, we have Dr. Jenna Jambeck, professor at the College of Engineering of University of Georgia and director of the Center for Circular Materials Management as our speaker. She will introduce us to the recent global trends and government policies and countermeasures. She will also talk about the importance of developing female researchers. Today's moderator is Professor Misuzu Asari, Associate Professor at Graduate School of Global Environmental Studies of Kyoto University. Professor Asari specializes on waste issues and environmental education. She has been observing and monitoring the livelihood of people around the world and environmental issues. She has been actively involved in awareness raising and educational activities from when she was a student and has been organizing various events. I'm sure we'll be able to hear interesting stories on efforts to solve environmental issues and prospects in Japan and the United States. After the presentation, we have time for Q&A. I hope you will ask many questions and participate actively. Now I'd like to pass the microphone to Professor Asari.
Alicia, thank you very much for the kind introduction. I'm Asari from Kyoto University. Before I introduce Dr. Jambeck, I would like to give you a little bit about the context. I believe that some of you are wondering why Kyoto University and US Embassy are working together to organize this session today. So I will explain why in the following slide. And another point is that I'm sure that many of you are here with us today because you are interested in the plastic waste issue. But another theme of today's session is promotion of STEM education for women. So I hope you will keep that in mind as you listen to the presentation. STEM means science, technology, engineering, and math. In Japan, there is a term rikeijo, roughly meaning science women, and to increase such science women, ministries and agencies are making effort. Please go to the next slide. However, if you look at the slide, you can see the percentage of female researchers. This graph includes both humanities and sciences, but as you can see, Japan is lagging behind internationally, and the percentage of female researchers will be even smaller in sciences alone. Japan is lagging behind. The US has about double the percentage, a little over 30%, but the US is still making effort to increase the number. And I believe that you can see the outcome of these efforts and potential in the future from the talk by Dr. Jambeck today. So why Kyoto University and US Embassy are organizing this event together. I'll give you the background. 3 years ago, through an acquaintance, I was contacted by the US Embassy, and we had the privilege of having Dr. Jambeck over at Kyoto University to have a lecture. And in front of the students, we were able to hear the lecture by the doctor. It was a part of the tour around Asia to raise awareness on the plastic issue, and she stayed in Kyoto for several days, and she also went to the Lake Biwa. You can see the photo from that trip. And we had discussion on STEM education and how it should be. And the relationship continued, and today we are having this event. I'd like to say thank you to all the members of US Embassy for making effort to make this happen. So finally, I would like to introduce Dr. Jambeck. Dr. Jambeck's work needs no introduction, but I'd like to briefly introduce Dr. Jambeck. She is professor at College of Engineering at University of Georgia. She started working on solid waste management and issues related to that 20 years ago. And she is a well-known researcher in this area. And she's giving policy advices to various organizations. She's been awarded many prizes, including researches and how to go about with researches. She is promoting women in STEM. And I believe that she will talk about this in the presentation. She worked together with a dozen female researchers to study marine plastic issue in 2014 in the Atlantic, and in 2019 as National Geographic Fellow, together with international female researchers. She co-led the study in India and Bangladesh. And also she is promoting the participation of citizens in science programs, and she developed an app. I think that many participants are interested in this. I hope you will hear the talk by Dr. in this regard as well. So now, let's welcome Dr. Jenna Jambeck. Dr. Jambeck, the microphone is yours.
Good morning. So wonderful to be with you today. Just confirming everyone can hear me. All good? Great. So thank you so much for that wonderful introduction. It's just been amazing to have been to Kyoto University in 2017, and I'm so excited to be with everyone today. Next slide. I've got some pictures already from the world tour that Professor Asari just spoke about. And I have really had the honor of traveling all over the world with the US State Department, with National Geographic, and really seeing the people working at the front lines of our solid waste management systems, and especially those working in the informal sector. And it's such important and incredible work. And I'm going to talk about many of the reasons why I went into solid waste have to do with the fact that it so closely involves people, but also about the science of the issue today, and also I think really talking about the importance of women in STEM disciplines, and really kind of specifically working on this issue all around the world. Next slide. So plastic is a relatively new material, and we published a paper not too long after last visit there, and we quantified plastic that had been produced, cumulatively all around the world, and it was 8.3 billion metric tons. And that's a hard number to imagine. So even sort of thinking of it as 80 million blue whales, it's hard to imagine. And because about 40% of the plastic that we produce to be used has been used as single-use items or as packaging. That means that by 2015, 6.3 billion metric tons have already become waste. And what had we done with that waste? Well, we've only been able to recycle 9% of that material on average globally, and 12% incinerated, and that means that 79% either ended up in landfills or in our open environment. Next slide, please. So one thing I talked about on my last visit was our estimate of plastic entering the oceans globally. And that was ranged from about 5 to 13 million metric tons. But this map produced by National Geographic shows not only the input from land, but data of what's been found floating in the ocean and what has been estimated to be discharged from rivers, which we know has been a large focus of one of the pathways for plastic to get from land to the ocean. Next slide, please. So one thing I wanted to talk about today is an expedition that I was on all of last year, but took more preparation before last year. But let me give you some background on the Ganges River where we were working. This is a river basin that covers over 1 million square kilometers. It encompasses portions of India, China, Nepal, and Bangladesh. This is one of the most beautiful rivers in the world. It's got unbelievable diverse terrain, habitat, animals. It's also under stress as one of the most populated river basins in the world. About 400 million depend on the river and its tributaries. So it's a sacred and holy river to many as well. It's known in India as the Ganga, and in Bangladesh, the Padma, and then near its mouth as the Meghna. The river discharges a massive amount of water and silt and sediment with about an average 38,000 cubic meters per second. Next slide, please. So when I was there, we saw that the river was used for many, many reasons. And it sort of seems like it has vast and never-ending resources. But many of these are stressed already. But it's also used even as a solid waste management system by some because there's no other choices. So imagine that there's no place really to put your waste. So this can take it away. But depending upon the reference, the river is ranked second or sixth in the world for plastic inputs into the ocean. But this was all completed with just modeling, similar to the estimates that we had made in 2015. So this time, we'll collect empirical data. So in collaboration with many important in-country partners in India and Bangladesh, wanted to know more about the flow, load, and characterization of plastic pollution in the river basin. We designed the first ever National Geographic Sea to Source expedition and executed it last year, as I said. Next slide. So I'm going to talk a little bit about our route. As I mentioned, it started early in 2018 with planning, but after practice and trial work, April of 2019, we began in May at the mouth of the river in Bangladesh at a community called Charfasha. The river was wide, really wide. It looked really almost like the ocean, 11 kilometers wide, and it really heavily impacted by the tides coming in and out. And in fact, which I'll show you in a minute, it often felt like we were on the ocean instead of a river. The flow and discharge of the river is massive here and kind of incomprehensible really in some ways when you can't see the other side of the river. This was a small rural community. It relied heavily on fishing for folks' livelihood and sustenance with the common theme along much of the river. And we traveled by boat in Bangladesh to each one of the cities. So we went to 3 cities or villages with the next city was Chandpur, which is more of an industrial city with a lot of boat traffic. and then the last city in Bangladesh was called Rajbari. From there, we actually had to fly to Kolkata to cross the border, and then we drove from there to our first site in India. I have to say the road trips of our caravans of vehicles were pretty epic, and we were always trying to guess when we actually might arrive at our next spot through many of the different terrain and different sort of road status that we would end up on in India. So our first site in India was called Sahibganj, which was also a rural site with both agriculture and fishing based. After that, we went to Patna, and there we could take a train, which was great. And Patna was our largest city, and we worked on in the whole journey, and it has 2 million people. But this is still a very small city for India, but definitely a very large urban environment. After that, our next city was the holiest of cities along the Ganga, Varanasi. We witnessed ceremonies of gifts to Namami Ganga. In some cases were actually plastic, but some were natural. This is also a bustling city of about 1.2 million people with high tourism and people coming to visit and bathe in the sacred river. After Varanasi was a small rural town called Kannauj, and this was the first time I had actually ever seen cornfields within India. And in fact, I'm actually where I am right now is where I grew up in Minnesota, where I'm used to seeing cornfields as well. And after that, next we went to Anupchahar, which is somewhat of a similar and small rural city within India, and actually had the smallest population of where we visited. The next site was called Rishikesh, which is a well-known and touristy mountain community that visits for river rafting and mountain hiking, as it's right on the edge of the Himalayas. And then the last site was the source of the Ganga. We're very near the source of the Ganga in Harshal, which was a 10-hour trip up into the Himalayas by car and just south of Gangotri, which is the town named for the glacier of where the river starts. Next slide. So this is our team. We represented 5 different countries. As I mentioned, we had incredible in-country partners, but what you'll hear is a lot of women. This was the first women co-led expedition. So I had a co-lead here. Her name is Heather Coldaway. She's from the UK. And it was just an amazing, diverse team representing, a large global perspective on this issue, as well as the in-country partners who really drove some of the science and the questions that we were asking. Next slide, please. I want to give you a little bit of behind the scenes on what life was like. So I'm going to show you the boat that we lived on in Bangladesh, a small, simple river boat that we were able to stay on. And I have to say, it was very hot. The first part of our expedition happened in May and June, which was a very hot time to be living on a boat with no air conditioning. But we worked around it. We did a lot of our work in the early mornings so that we avoided much of the heat in the middle of the day. Next slide, please. And so we took surface water samples in the river, as well as sediment samples in the river. Also did some dredging of looking for plastic that had settled on the bottom of the river. So a river was definitely the focus of the water team on this trip. Next slide. We also sampled air. So some recent research has come out, and I think you may be, well, if you haven't heard, so they just measured microplastic in sea spray. So even just being along the beach and, feeling that nice sea spray, you might be having microplastic coming onto shore. So we wanted to measure air within the river basin. So we took air samples, went to fish markets to see what kind of fish were sold, what kind of fish the fishermen were specifically catching and how this issue might be impacting their catches as well. Next slide. We also, for that fishing part, started to do a net survey. So what we were looking at is what some of the net pieces were sort of ending up along the river, how people were managing nets at their end of life. But we also heard a lot of stories from fishermen about them catching plastic instead of fish within their nets. So that was sort of the interface. Next slide, please. Sorry. That was sort of the interface, right, of the river and the land. And then we had a land team that was specifically looking within the communities. And we were using here a protocol that we now have developed at the University of Georgia called the Circularity Assessment Protocol. And this is a way of taking a systems approach of looking at this issue in some sort of geographic boundary, a city, a community, but it's a hub and spoke model with these 7 spokes, all the way from input of, you know, what are people, what's available in the stores to people and how is it packaged. So we're looking at plastic and packaging, and then what are people actually buying and how are they using it. And then we're looking at how this packaging is designed, what materials it's made out of, are there alternatives, are there reuse options, and then we look at collection of materials. Is there a good collection system? And then how is it managed at its end of life? Is there a lot of recycling happening? Are things getting landfilled or burned? And then last but not least, we look at leakage and we look at what's ending up on the ground to inform really all of these upstream interventions, and some of those I'll talk about later. Next slide, please. What this data looks like is random stratified sampling within communities where we can collect this leakage data and actually see in terms of, you know, what's ending up on the ground, but then it's more about what, but it's why and how. And then we ask together with the community and our stakeholders, you know, what can we do about that? Because what can we do to prevent that? Next slide, please. So you can see some of the data and some of the items that we found, and then you're going to see litter densities. So here we have mapped not just the litter and the items ending up on the ground and their density, but also potential influencing factors. We map all of the waste and recycle bins. We map stores and to-go restaurants. We also map parks and, you know, religious centers. And so it's really about this sort of on the ground mapping and sort of observations to be able to collect this kind of data. Slide. But we're also just collecting this quantitative data. We're collecting qualitative data as well. So we talk to people. Lots of folks within the community, but to investigate and find out what's being sold in the markets and in the stores and how it's packaged. And like I said, looking at sort of alternative materials, alternative delivery systems for products. So it's a lot of interviews as well. Next slide, please. We're also looking at how the waste is managed. And I kind of mentioned at the beginning, you know, sort of imagine if you don't have anywhere to put your waste, where will it go? And a lot of communities, you know, I think historically we've had a lot of local dump sites. And when this material was not plastic, you know, much of it was not having the impacts that it is now. A lot of it used to biodegrade or be sort of inert if it was something like pottery or ceramic, but that's not what plastic is like. And we know that it degrades over time into microplastics, persist in the environment. it sorbs persistent organic pollutants, and we saw lots of animals consuming the plastic, terrestrial animals, so the cows and some of the grazing animals within India as well. So it's not just impacting the ocean. Next slide, please. So part of our work also entails using marine debris tracker, which I think you heard about in the introduction. This open source, open data mobile app that I co-developed with one of my colleagues at the University of Georgia is actually our tool of data collection. And it's not just available to us, it's available to everybody in the world. So all of you can also use this tool to join us around the world in collecting this data to inform these upstream solutions. Next, please. So in India, a large portion, I mean, the data varies, but probably 60, maybe even up to 80% of the waste, and especially the recycling, is managed by the informal sector. So we conducted interviews and talking to folks. They're called kabadi wallas, but these are junk shop owners who buy the materials that folks collect either from households or sometimes from the dump sites, and then sell them to processors. Next slide, please. We also had an entire socioeconomic team that met with folks in the villages around some of these cities in doing household surveys and focus group to really measure people's knowledge, attitudes, and perceptions related to plastic use within their community. Next slide, please. So some of our methods are fairly, traditional and well established, but we also used some sort of new leading edge technology. I know folks in Japan have used similar technology, but we had a drone pilot and a collaborator, Lipsis Environmental, and they flew a drone and were able to use artificial intelligence to be able to detect and quantify the plastic that was seen along the river. So again, this was the interface between the water and the land. Next slide, please. We also built an open source tracking tool. So this is another more high-tech aspect of the expedition. And we had a technology team partnered with folks on our expedition team to develop these trackers that had cell and satellite GPS signals that were able to be tracked, wondering if you do drop a piece of, an item into the river, how far does it actually go? And so we're crunching data now in terms of being able to see what these us, but yes, they gave us GPS tracks through the river. Next slide, please. What I want to talk about here is the thinking about as we, quantified the plastic sort of ending up in the waterways and ending up in the ocean, all of the potential places to intervene to reduce that amount. And the data that we collect through this expedition and within the communities of where we can intervene and reduce this quantity. Go ahead and click one more time, and I'll show you that, thinking about this, this end component on how it can inform the changes that we can make upstream in the reduction category and innovative and materials design on how we can actually reduce that quantity. So next slide. Great. Yep, you can see that. Perfect. So thinking about way upstream, how can we, reduce that quantity? Can we actually reduce the demand that we have on plastic? So this is our individual choices. And, I think I even touched on this somewhat in 2017. But I think those of us who have the luxury, that's why that word is there. We have the luxury of clean water, so we can make the choices everybody around the world does, and certainly many people in India did not, and Bangladesh. So if we have choices, we can choose a water bottle over single-use bottles and, reusable bags. Very simple choices, but definitely collectively those make a difference. They're hard choices sometimes because we sometimes don't have a choice, it seems like. And so that's when I encourage people to talk to talk to companies, talk to the store owners, talk to the government, make your voice heard on wanting to make those choices, but feeling like you can't. And that's where you make your voice heard and make change. Next slide, please. I think also using technology to, kind of reinvent some of our systems. So just one way is this company called Loop, where you can buy your products in reusable containers and they take them back. So, this is not a new concept. We've done this with glass bottles. It's been done for, other beverages and milk. But now, it can be done with our logistics that we have. So it can be shipped to your home. There's ways that you can embed radio frequency identifications that, things can be tagged to you and you can refill them yourself at refill stands. And so I think I get very excited about this, especially, talking to university students like yourself and professors. There's a lot of cool innovation that could be done here, even in a partnership between the US and Japan, for example. Next slide, please. Also, thinking about how we design our packaging. So as I mentioned, some of it gets recycled, and then we notice that some of it ends up on the ground. Ends up on the ground does not have value. And why doesn't it have value? Because the design is not in such a way that it retains any value. So this is directions on how to design a PET bottle so it does have this value. And of course, you put a deposit on a package as well, and that gives it value. But even beyond that, depending upon the materials that you use, if they're valuable, then it will be collected. And you can also promote this through an extended producer responsibility legislation model as well. Next slide, please. The other thing you can do is think about different materials. So this is my colleague, Dr. Laughlin at the University of Georgia, who is working on biodegradable polymers. A lot of folks at different universities are looking into how can we have a material that behaves and has many of the properties that we like about it. It can be molded, can be colored, but will biodegrade at the end of life, so we can manage it differently, or it wouldn't have some of these unintended consequences. So we work specifically with PHA as a polymer. So thinking about that as alternatives as well. Next slide, please. So those were mostly upstream options. What we also need to think about is our global waste management infrastructure. And as I said, there's still, places around the world where there isn't infrastructure yet. There's not a place to put waste. And so thinking about how we expand that. But one more click forward on this, like you're going to hit next slide, will show you that I really think besides collecting, capturing, and containing this waste, we really need to think about the context and culture of where we're doing that, like the folks in the informal sector, people who are already doing a lot of this work. How can we include them and actually go to them as experts in how we can build up and scale these systems so that people actually do get proper waste collection and management around the world? Next slide, please. And then lastly, we're going to talk about that last chance for capture. And so this could be engineered devices, like you'll see the Baltimore water wheel here and other catchment devices. Or next slide, please. It could be also manual, which we've been doing for many, many years and a long time, our cleanups. But I think what's really cool now and very important to this is that people are collecting this data. So, or collecting data in better and faster ways, like the mobile app marine debris tracker, you know, and there's others out there, but we're actually using the data from our cleanups. Next, please. Using this data from our cleanups to be able to inform those solutions, I think, has been really a critical step forward. And so luckily we've got some partners now that are really expanding the reach. So Debris Tracker is now powered by Morgan Stanley, and National Geographic is using it as a part of their education campaigns. Next slide, please. So as I said, we used it for the expedition as a scientist, but also as a scientist and engineers, but also the communities. We held workshops and they got training on using the mobile app as well. And it really can empower people to collect data and help inform their decisions. Next slide, please. So holding workshops in the communities, but then also developing curriculum and education within the schools. This is another really great way to involve women in STEM. And, you know, certainly it was pretty amazing because we went back twice to the expedition. So one of the places we were collecting data, we were meeting, you know, people in the communities. And for example, this one girl who we had collected down her street in May, we went back in October and she came out again and said, I remember you. I've been, you know, following you on Instagram, and, you know, and I have the tracker, and it was just really great to see that inspiration within the community as well. Excuse me. Next slide, please. So I just want to, you know, welcome everybody, I think, into this science, thinking about, you know, what you can do to help this issue, to join us, you know, think about STEM disciplines and how they can, you know, contribute in terms of helping us reduce the quantity of plastic getting into our environment, you know, thinking about alternatives and, you know, working together with us on this issue. Last slide, please. And just, you know, thank everybody who already is working on this issue. Thank you again to the State Department, Professor Asari, and everyone at Kyoto University and the Embassy for hosting me, and look forward to a nice Q&A session here moving forward.
Dr. Jambeck, thank you very much. You became even more powerful as a researcher, I believe, and it's great that you're working with people around the world. Thank you for your presentation, and most of our audience today are Japanese, and they know you from your papers and from your name, but it's rare for them to be able to interact with you directly, and some of them may be a little nervous. So as a warm-up, we would like to do polling using Zoom function. Kana-san? So here's the first question. Just follow your instinct. Don't take too much time. Please select the one that you think it's appropriate. Thank you. What actions are you taking to reduce the plastic you consume? You can choose multiple answers. Please take some time to answer the question. So when is the good timing to move ahead? Oh, I see. Great. So that was the first question. So here's the next question. How can people who want to take action make the largest contribution?
改めて感じるお話でしたが、どうでしょうか。
We heard some interesting stories from Dr. Jambeck.
すごい、だいぶ今日のお話で影響を受けているような。
I see. I can tell that people were very inspired by Dr. Jambeck's presentation.
はい、教育を通じてプラスチックについてさらに理解を深めるために、
How can education programs about plastic be most effective?
Oh, やっぱり環境教育の中
I
の
see. Should be a part of standard school materials. I see.
私今は環境教育論ですので頑張らなければいけません。
My specialization is environmental education, so I should work hard on this. So, question 4, to understand the current situation of gender equality in STEM field, what are the most significant barriers women face?
これは立場によって随分見方が違うかもしれません。
I
なるほど。
see.
今回コロナ禍で改めて家庭の仕事の
With
重さを感じられた。
the spread of coronavirus, many people felt the difficulties of balancing work and life. Thank you very much for your participation, and we'll analyze the results further, and we would like to make good use of the results. Now we would like to move on to Q&A. Please use the Q&A box to submit your questions. We have already received some questions at the time of the enrollment registration. So we would like to start from those questions while you're writing in additional questions. Thank you. So first question, I'm sure this is on many people's mind. How COVID-19 will affect plastic recycling and including research on plastic. Dr. Jambeck, your thoughts, please?
Sure. So I know that in several places, COVID-19 has impacted recycling in the United States. What we saw was a large increase in waste generation in the home, and obviously with people staying home, and then less generated in the workplace. So that just changed our characterization of waste coming out of just, our waste being generated. And we also saw economic impacts to our recycling industry. The waste folks are on the front line, so they had exposure issues. In India, my colleague said that while waste was considered essential, recycling was not. So the recycling was just piling up. So, and not getting processed. They weren't allowed to be working. I think that exposure issue was kind of critical in terms of safety, right? And so I think that's a question here. So, learning more about how long the virus lives on plastic has been important. And that actually relates to our use of plastic. I think a lot of people have thought of plastic as being much safer during this time, but considering the virus does live on plastic, as long as you wash in soap and hot water items, they can actually be still reused. And so that's just something to think about and consider as we look at this issue and how it's been impacted by COVID.
はい、ありがとうございます。私たちも日本の中
Thank
で
you
も
very much. In Japan as well, we are also thinking about the impact of coronavirus. As for the waste management in Japan, a lot of people stayed home and they tended to clean their house. And as a result, many household garbage and waste were generated. And also, how about the hygiene and how should we recycle and manage plastic waste? That is, I believe, a global challenge that we have to tackle, and we should collaborate in tackling that issue. Next, about the individual behaviors. I think that in some of these slides, you already touched upon this. Individuals' actions are important when it comes to reducing amount of waste and choosing alternatives. So their individual choices collectively matter. So what this person is concerned is to what extent should we make an effort? Because zero plastic is something that some people are aiming to achieve, but what do you think about the extent of to which people should make effort in this regard?
Hi, everybody. Sorry for the delay on the audio. I was switching to my phone. So thanks for that question. So I think that it's about the level of effort on sort of switching away from single-use items to reusable items and going, zero plastic. So that's a great question, because I think it's something we all want to aspire to do, but it's also hard, I think, in the systems that we currently have. I'm a busy parent, and I think if we try to do it all at once and actually go zero, it's challenging and it can become overwhelming, and you want to kind of just quit because it's too much. So I always talk about kind of doing one thing. And so people said, the reusable bags, I think, was one of the things that folks thought, that's one of the main things we can do. It's one of the easiest things we can do. Plastic bags are the most dangerous items, film plastic, that ends up in our environment. I would agree with that. Then, the reusable water bottles, which I found many people in Japan already using. And I think you can kind of take steps, but I think the key here also, as I mentioned, is if you have trouble doing this, if there's not like bulk things at the grocery store so you can avoid plastic, you need to try to communicate to the store, to the companies that are making the products that are, using all of the single-use plastic that you're trying to avoid. And so, then we can change the system so that it's easier for us to do this. So it's kind of a little bit of both, but it takes a lot of energy to do that, and it's hard in our current system.
はい、ありがとうございます。次のスライドちょっと見せていただい
Thank
て。
you. If we could go on to the next slide. This is what we are working on at Kyoto University. In the latter half of the Q&A, we would like to touch upon Japanese policy, but Japan issued a plastic recycling strategy last year, and we have set numerical targets as well. But in order to achieve that goal, it's important to gain understanding of general public and so that we can start changing people's behavior. At Kyoto University, in order to coexist with plastic, we have started Pride initiative. It's a collaboration between Kyoto University and a magazine called Frau, which is a fashion magazine. Frau has issued the SDGs special edition as well, which is a very rare thing for a fashion magazine to do. And they looked into what's in a bag of a person, and they analyzed how much plastic there was. There were about on average 50 plastic items in a person's bag, and some items has to be in plastic, and we created chart need to be plastic, no need to be plastic. That's on horizontal line, and we would like to use this chart to influence people, general citizens, and also the companies and etc. And we will have a YouTube live session on August 1st on this topic. There was a little bit of a publicity of a program, but just wanted to introduce this initiative to Dr. Jambeck as well. Next slide, please. So lots of words on this slide, but Dr. Jambeck introduced us to many of the countermeasures, and we need to think about effectiveness and challenges of various initiatives and countermeasures. It's important to reduce the overall amount of plastic waste, and we need a system so that they don't end up in ocean, and maybe produce plastic that is less stressful to the environment. So what are the potentials of these various initiatives, if you could elaborate? And we are interested in knowing your future plan for marine debris tracker as well. And also, how do you estimate efficiency of so-called biodegradable plastics? And are there any things that we need to watch for in using them? And another one on recycling. Some say that there is no problem as long as plastic waste is recycled properly, but are there any problems to it? Some items needs to be recycled through thermal recycle process, and we would like to know what you think about the thermal recycle. And this is a specific pollution source, and fishing is oftentimes thought about as producing plastic waste. So can you touch upon the issue with fishing? Thank you very much.
Great. A lot of good questions here. I think I'll touch on the biodegradable question here, because I started talking a little bit about those, and I think it's important. There's bio-based plastics that are made from plant material, and those may or may not be biodegradable. And then there are plastics made from fossil fuels, much of them petroleum products, but also natural gas. And some of those can actually be biodegradable. And basically, the biodegradable means microbes convert the carbon either to carbon dioxide respiration, or if it's anaerobic, to methane. And so I think we need to be very thoughtful also about where we use this material. because things that are highly recycled right now, we don't want to disrupt that system, right? And also, if we are expecting people to compost something, they need to have access to some place to compost that material. So I think that's important to consider. So we have a new project where we are assessing the entire compost infrastructure within the US to look and see if we converted some materials over to that. And when we talk about some of the film plastics that are not currently recycled and some of the food packaging, you know, those might be candidates for something like a biodegradable material. But another nuance is that the additives, so all plastics contain additives and colorants and things, all of those things also need to be biodegradable and not harmful for the environment. So there's still, I think, a lot of things to consider within that space. Next, I was asked about, you know, issues related to plastic recycling. And mechanical recycling, I think, has challenged because of what makes plastic so useful, you know, that it can be hard, it can, you know, rigid, it can be, you know, film-based, it can be soft, and so many colors, it's actually then very challenging to get it separated and recycled cleanly. So another paper that we published in 2018 was about the export of plastic scrap for recycling, and both actually Japan and US exported a large quantity of our materials to countries like China and other lower income countries for this recycling. And that's because we don't have the infrastructure, at least US based. For us, I can speak to that. We don't have the infrastructure to do much of the recycling here, and it's much more expensive. And now China has stopped taking that material. And so we're changing our whole recycling systems as well, and that remains something that we're working on. Somebody asked about thermal recycling. That right now is not scaled yet to the point, so people also refer to this as chemical recycling. So it's taking the plastic, which is a polymer, getting it back down to a monomer, either through gasification or pyrolysis. And it sounds very good and promising, but yet at the same time, it's been very challenging and expensive to scale. So I think that is also something we want to entirely rely on as well. And I also want to touch on the STEM question. I think was asked about sort of the difference between women in the STEM fields between our two countries. And I think just in general, how can we foster an environment where women feel, you know, welcomed? I think the culture of our, and I can speak to the US, I know that I can give the reason for the difference between the US and Japan, but I think our work environment culture highly impacts that. And when women are thinking about balancing home and, you know, family and just home life and or if they choose to have a family as well as the job, it becomes, you know, it just feels like it's not possible. And so that was, I want to stress, one of the reasons we had a co-lead of our National Geographic expedition. Those have typically been run by men. They're gone from home for many, many months. And Heather and I said, we want to do this differently. We want to do this together so that neither of us were gone more than 3 weeks at a time. And yet this 4 month, you know, we took turns and this 4-month expedition happened. And I think, you know, why not change the culture and the environment and the systems, again, that we're working in to make it more useful for everybody. Both women and men don't want to be, you know, gone from home that long. So I'll leave it there to see if there's more questions based upon what I saw in the chat. Thank you.
はい、ありがとうございます。そうですね。
Thank you very much.
日本はさらにそれがきつ ついところもあるのかなっていうふうにも
In Japan, it may be even harder to achieve that. Now, in this slide, regarding the mobile app, Marine Debris Tracker, the future rollout of this app and implementation, that's what I'd like to know. If we want to use the app, what should we do? Can you elaborate on this? Thank you.
So Marine Debris Tracker is available on both Android and Apple, platforms, excuse me. So in either of the stores, it's available. It's very simple now on the website, which can make sure all of the participants can get access to the website. There's a user guide in a document and PDF format. We also just finished creating a tutorial video and a promotional video with the help of Morgan Stanley and National Geographic. So those will be coming out very soon. So it's very easy to join, and I have help with a coordinator within my group. So different organizations can make their own list because we find that, although many litter items are the same around the world, there also are items that are very site specific. And so you may want to have your own site specific list of items that you typically find. And also to create a group, like Kyoto University could have their own list in terms of being able to brand it and have folks join that initiative. Let me know if you want me to answer another question in the chat. There was one on the percentages of sort of what is the most use of plastic around the world, and a comment that plastic bag use is low. And I think what you'll find is that, and I'll just answer this quickly, plastic bags don't weigh very much. So when you're measuring by mass, of course, that quantity is going to be low if they tend to not weigh a lot, but by numbers, it's different. So it's very much, different metrics. So in waste, we measure by mass, but when we do litter, we measure by count. And really, is the mass what matters to the turtle that sees, plastic bags, many numbers of plastic bags in the water. And so when we think about sort of risk, we need to figure out the material flows are mass, but then numbers are very important. So it's not always what the most sort of mass is as well. But you're right, some of the things that don't weigh a lot are not a big portion of that production number, but 40% of what we produce. So that the largest fraction of what we produce are single-use items and packaging. That is the majority of what we're talking about ending up in our environment.
はい、ありがとうございます。そういう意味では、今の、
Thank you very much. It's a related question. There's already plastic in our ocean, and is there research going on to tackle the issue of existing plastic in the ocean right now? And what can citizens do to reduce ocean plastic? I think Jenna already addressed this. Start avoiding single-use plastic. Don't litter, and then clean up the beaches, so forth. Small things make a big difference in the end. But going back to the existing plastic waste in the ocean, what shall we do? Any thoughts?
So you're right. There is existing plastic within our oceans. Within our ocean, and then in our environment. And so you can kind of think of this as your bathtub is overflowing. What is the first thing you do if you walk in? You're gonna have a nice bath, and so you turn it on and you forget, and you walk in, your bathtub's overflowing. You're gonna go and turn off the tap. right away, right? Because if you start mopping up the floor, it's just going to keep, you know, coming. And maybe you'll grab a couple things off the floor quickly that you can salvage. And so I think of it that way. So there may be some things that we do want to get out of the ocean. One of the things is derelict fishing gear. You know, I mentioned fishing was quite important in the Ganges River. Obviously, within Japan, fishing is an absolute critical industry. And so thinking about for us here in the US too, we see a lot of derelict fishing gear or fishing gear that ends up on the coastlines or in the ocean. That's something that we can, it's large in size, we can get it out. Other items within the gyres, and I showed that map of sort of where it was ending up in the ocean. It gets quite small. It's very hard to capture. It's, you know, not economic or efficient or even effective to capture it that way. So we want to think about ways to sort of turn off the tap. And the other thing is that research has shown that the ocean, well, cleanups are effective in this because the ocean does sort of spit this plastic back out at us in many cases. And I witnessed this myself before I sailed across the ocean. So something I talked about in 2017 was sailing with all the women. So we were specifically promoting women in STEM as we sailed across the Atlantic Ocean. But before we left from the Canary Islands, I was standing at the ocean and each ocean wave just had plastic, you know, washing onto shore. And that's where you could capture it and help sort of remove it from the ocean that way. But some of the other ways that are not near shore are very challenging. So we want to think more upstream.
Thank you
very much for that. So what needs to be prioritized is to stop the generation of waste in the upstream. Now, we don't have much time left, but we have a lot of questions coming in. So we want to go to the last slide first, and then we want to have many questions answered before we close the session. So the next question is about the policies in Japan, and also other questions were around policies and politicians. How should we approach politicians so that they will work on this issue? There were similar questions. So regarding Japanese policies, if you have any views, we'd like to hear from you. And also on politicians, how should we interact with politicians? What can we expect from politicians? And another question, for example, in India and in Pacific countries, which are my specialties, there are rural villages and communities, and they have less options. They don't have many manufacturers. So what should they do in these rural communities? So can you touch upon these questions in your response?
Yeah, thank you for this question and for all your efforts. And Professor Asari has been doing incredible work. I know you mentioned, you know, people thought education, you know, requirements were quite important to, you know, making change within with this issue. And I love the books Professor Asari and her group has created. They're tremendous books. We don't have anything like that in the US. But I can say what has been helping here is a lot of communication, you know, seminars like this, but not just within the academic setting, but outside of that academic setting to communities. But I've had the opportunity of talking to government officials. So, you know, if there's opportunities to talk to legislative members or bodies, I've testified to our Congress 3 times. It's amazing to be able to do that as a scientist. And so, you know, if the decision makers want to hear about the science, that's where you really have an opportunity to spread awareness and about this issue to folks that can make policy. So somehow the science has to get to the policymakers, and sometimes there's communicators that do that, but I think it's very meaningful for it to come directly from the scientists. So I would encourage folks to be able to, you know, find the routes that work best for you to communicate directly to them. But then, of course, the citizens as well, they need to hear from that, because they're going to hear the science, but they also need to hear from the constituents that that they want to see changes as well. I think what's been interesting about Japan is because the waste management systems have been so effective and efficient, you know, they work very well, sort of how they are, that people don't realize that there's all this waste, and there is still some leakage, because, I mean, the best thing you can do environmentally is not produce waste in the first place. But it's so well managed and very clean in many areas of Japan. And so I think it's just not on people's sort of radar that this is still an issue, even with all of that, because, you know, eventually you run out of space, even if you do incineration. You know, it's better not to produce waste in the first place. So, yep.
はい、ありがとうございます。あとですね、先生が何人か聞いておられるんですけれども、
We have some questions from professors. Do you have any textbook recommendation for this topic? I would recommend, if you go to the website of our environmental ministry, this is for mostly high school and junior high school students. There are a lot of free materials that you can use. So that's what I'd recommend. And for college students, please search Dr. Jambeck's name, and you will be able to see her papers, and her papers are quite easy to understand, so I would recommend her papers.
Yeah, so that's a great question about textbooks or what books or materials that I would recommend. So there's been a lot of good reports. I think I saw there was a potential discussion related to the Gazamp report, and they have produced some reports, and that's a conglomeration of scientists from around the world. There was an edited volume, so there isn't a textbook entirely written by a single author, but there was a volume of edited papers that was a book, probably focused more on microplastic than the other plastic. I have to admit, I was starting a textbook and have not been able to finish that, which this makes me wish I had. Of course, but yes, I mean, I think gathering papers, one reason why it was so challenging to try to finish that is that this issue is so dynamic. It is changing so quickly. The science has increased exponentially, just like the production of plastic curve. It wasn't, when I first started this, it wasn't even recognized as a scientific discipline. I started this in 2001, and so it really has grown. And so it is true. Professor Asari says, look at the recent papers coming out. I mean, some of the established papers, the big papers, that I've had the honor of participating in, but there's others in terms of recent work as well. I mentioned the sea spray paper. They just found 1.9 million plastic pieces per square meter in the depths of the ocean. They're finding it in our, highest mountain peaks. There's going to be some new papers coming out about that. And so, yeah, I think the most recent literature is the best kind of place to go to find that information. I see there was something, I want to touch on a question that I missed here about rural communities, and that right now I'm extremely rural in Minnesota, and so even in the USA, we have rural communities. I was in Alaska in January, or early February, excuse me, and we still have very remote and rural areas there. And so that's where we need to get really thoughtful with, you know, what we can do and have, I think they're decentralized and a lot of waste segregation, composting as much as possible. Rural usually means you have area, hopefully, to work in. And so being able to keep organics separate from other materials, try to only bring in packaging that can be recycled, think about how products come in, can the recyclables go out the same? And I know Alaska does a lot of that. And so, you know, trying, again, being very thoughtful about what comes into that community and not just, you know, I've worked also with islands. So island nations have this issue as well. And Japan thinks about this. I mean, what are you going to procure? So one small island developing state that I worked with really had even bans, limits on the kind of materials that they accepted because they just couldn't manage some of them. And so I think that's the same way that you have to think about in rural communities.
Thank
you very much. So the responses and measures in rural communities, I think that they might have some new and fresh perspective. And they have the spirit of mutual help in these rural areas. And shared scheme, which is spreading in urban areas, may have good affinity in rural areas as well. So maybe we can go to the next step from the plastic culture, so to speak, in these rural areas more easily. So let's exchange information on that continuously. And I'm looking forward to your paper. I will translate your paper into Japanese. Thank you. And we have many questions coming in, but time is limited. So let's look at some other questions. Some Japanese researchers are also asking questions. And regarding Japanese researchers compared to the US, there is a smaller percentage of female researchers in Japan, but it's one of the important goals in SDGs. So international comparison should be made based on specific cases. And we have to learn from the cases in the US. Many female students who are being enrolled in the university are very active. So I think that the situation will change soon. So we've been having a very good time. It's a wonderful opportunity, but we have a limited time. So before we close, we want to hear from Dr. Jambeck. We have a lot of Japanese diverse members in the audience. I'd like to have the closing remark from the doctor, please.
Well, I just wanted to say thank you so much to everybody. And I think I just kind of glanced through some of these questions, so I can just quickly. Somebody asked if I had heard of the app called Literati. Yes, and that's something that came out after our app and is used more by companies through their community and social responsibility initiatives. As far as I know, they're not open data, something that we strongly believe in being with our data. Oh, here's a good one about our administration. Do I think things will change after the election? I think what has been really, really interesting and I'm grateful for about this issue is it remains very bipartisan. And this is really, you know, I find this to be true globally. Really, it doesn't matter about your politics. Nobody likes plastic in the ocean and in our environment. I think there are some discussions on what the right solutions are, but something I'm very grateful for is that we all agree that that's not where it belongs. And so that sort of moves the discussion forward, and we can have, you know, further discussions about solutions. And as I think I illustrated, there's lots of solutions needed. It's not all just one or the other. And so that sort of opens up opportunities for everyone to really have input and perspective and have part of those different solutions implemented. And I guess the other thing is that if it's possible to, you know, see some of these questions, I'd be more than happy to try to, you know, answer them in a different way through writing some, you know, answers back through a document that can be shared with folks. I'd be more than happy to do that. And I would just love to see the collaboration between our university in the US and Kyoto University and Japan grow. I think you all are doing tremendous work. Japan is working as a country with the United Nations on various initiatives, and I'm just very grateful to Professor Asari and all of her work and everybody's work there at the university and within Japan on this issue. And so I really look forward to hopefully having a bit more time to cultivate more of a collaboration and relationship moving forward. And thank you again to everybody for your attention and great engagement and questions on this seminar.
ありがとうございました。ぜひ次につなげていきたいと思います。
So looking forward to our next engagement, and we would like to continue learning about this topic. I would like to thank you all for your participation, and I'd like to pass the microphone to Alicia. Dr. Jambeck and Professor Asari, thank you very much. I would also like to thank all of you for your participation and for asking great questions. We were able to have a very successful program thanks to all of you. The Public Affairs section of the U.S. Consulate General is organizing activities and programs to promote cultural exchange and mutual understanding between our two countries. We are conducting a program like today's on a non-regular basis, so please check our Twitter if you're interested. And we are also providing advice for study in the United States. If you're interested, please contact us. Looking forward to seeing you again soon. Thank you very much.